Hello, my name is Subbareddy Darukumalli. Today I am going to present an axial calibration of an on-mission focus variation sensor. In this research, we used an on-mission focus variation sensor prototype which has 80 millimeters of diameter and 180 millimeters of height and which can be easily mounted to the conventional manufacturing machines, which has a specification of 20 millimeters of g-axis travel range. But for this specific experiment, we consider 15 millimeters as the actual working travel range and a 20x magnification and ring illumination as the light source. In this experiment, we determined the amplification coefficient and linearity deviation following the ISO 25178 part 600 standard and the maximum permissible unidirectional stationary error (EUNIZ) following a derived method from ISO 10360 part 8 standard. To determine these metrological characteristics, we use 8 different step heights varying from 0.24 micrometer to 3000 micrometers used as the material measures. All these 8 material measures were measured at 5 different measurement positions, starting from 90% of the working range till 10% of the working range within continuous intervals. We computed the step height values in 4 steps. The step 1 is the measured data. The measure in step 2, the measured data was leveled to the workpiece coordinate system. In step 3, we choose the profile direction and the profile width. In step 4, we computed the step height values. The deviations of the step height values, the measured step height values were reported in this graph. The x-axis is the measured material measures and the y-axis is the amount of deviation. The maximum deviation reported as 0.13 micrometer and the estimated measurement uncertainty is reported as 0.36 micrometer. In total, the maximum permissible length error is reported as 0.49 micrometer plus or minus length over 2500, where length is the length of the sample in millimeters. The amplification coefficient and linearity deviation at all positions was reported in the table. The mean is computed as the amplification coefficient of the g-axis, which is 0.9999, and the absolute maximum of the linearity deviation at all positions is reported as the linearity deviation of the g-axis, which is 0.208 micrometer. In this paper, we propose a procedure to quantify the amplification coefficient and linearity deviation of the on-machine focus variation sensor. In near future, we want to look after the other metrological characteristics aspects of the on-machine focus variation sensor. Thank you.